Now, the chapter sets and the exercise 2.4 problems and solutions from this exercise 2.4. Here is the first question. State which of the following sets are empty sets. The set of straight lines passing through a point. The first bit is the set of straight lines passing through a point. If I have given a point, for example, you take this as point, then how many lines you can draw passing through this point? This is one line, second line, third line, fourth line, fifth line. Like this you can draw infinite number of lines passing through a single point. Therefore, since there are infinite elements in this set, it is not an empty set. What is the question? Question here is state which of the following sets are empty sets. Now, is it empty now? Good. This is not an empty set. Why? Because there are infinite number of lines can be drawn passing through a single point. Therefore, which is a non-empty set and it is an infinite set too. Second bit. Set of odd natural numbers divisible by 2. Any odd number is divisible by 2. We know that if a number is not divisible by 2, then only it is called an odd number. Since it is an odd number, it is not divisible by 2. Therefore, there is no such odd number which is divisible by 2. Therefore, the solution is it is an empty set. Number of odd numbers divisible by 2 is 0. That is, no odd number is divisible by 2. And third bit, x is such that x is a natural number and x is less than 5 and greater than 7. You see, here this is the set builder form. We have to write a natural number such that it should be less than 5 and at the same time it should be greater than 7. Here it is not or, it is and. And means that number should satisfy both the conditions. Means the number should be less than 5 and at the same time it should be greater than 7. For example, if we take 4 is less than 5 but it is not greater than 7. If we take 8 is not less than 5 even though it is greater than 7. Therefore, you cannot write any number which is less than 5 and at the same time greater than 7. You cannot find any such number. Therefore, it is an empty set. No natural number satisfies the given condition. Now, fourth bit, x is such that x is a common point to any two parallel lines. X is a common point to any two parallel lines. When can you say that the two lines are parallel? If two lines are said to be parallel if they have no common point. If there is no intersection point, then only they are said to be parallel lines. Since they are parallel, there is no common point at all. Since there is no common point, it is an empty set. Empty set. The parallel lines cannot have a common point at all. Fifth bit. Set of even prime numbers. Now, how many even primes are there? The prime numbers may start from 2. 2 is an even number. Next prime number is 3, 5, 7, 11, 13, 17. All are prime numbers. Except 2, remaining all are odd numbers. Therefore, there is an even prime which is 2. Okay. Therefore, this set contains even primes has only one element 2. Since there is an element, it is not an empty set. It is a singleton set at the same time. Non-empty set, because 2 is a prime, even prime, it is a singleton set. Sixth bit, set of integers that lie between 2 and 3. Is there any integer between 2 and 3? If you write integers may start from minus infinity, minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on. Therefore, there is no integer between 2 and 3. Since there is no integer, it is an empty set. There are no integers between 2 and 3, therefore it is an empty set. Now question number 2. Which of the following are finite sets and which of the following are infinite sets? I shall repeat, finite sets and infinite sets. When can I say that a set is finite? If the number of elements of any set is countable, then it is a finite set. If the elements of any set is uncountable, then it is infinite set. Okay, look at the first bit. Set of months in a year. You can calculate the number of months. Actually, there are 12 months in a year. Therefore, since you can calculate the number of months, since you can calculate the number of elements in this set of months in a year, it is a finite set. Second bit, set of 1, 2, 3, etc. 99 and 100. You can count how many elements are there in this set. There are 100 numbers. Therefore, you can count the number of elements in this set and it is a finite set. And third bit, set of primes less than 99. Set of primes is infinite, but set of primes less than 99 is a finite set. Actually, there are 25 prime numbers below 99. Therefore, it is a finite set as it is countable. Now, question number 3. Which are the following are finite sets and which are infinite sets? First bit, the set of letters in English alphabet. You can count the number of letters in an English alphabet. Actually, there are 26 letters. Therefore, it is a finite set. The set of lines parallel to x-axis. If you take x-axis, you can draw infinite number of lines parallel to x-axis. Therefore, it is an infinite set. Third one, the set of multiples of 5. In order to get the multiples of 5, you can write 5 into 1, 5 into 2, 5 into 3, 5 into 4 like this. Therefore, the multiples of 5 are 5, 10, 15, 20, 25, 30, 35 like this. You can write any number of multiples. Therefore, it is an infinite set. There is no end to this. Fourth bit, the set of circles passing through 0, 0 origin. Passing through origin, how many circles you can draw? You practice, you try. If you try means 0, 0 is a point. Passing through one point, you can draw infinite number of circles. You may try once. So that you may understand that this set contains infinite number of elements. Therefore, this set is an infinite set. Now, this is the end of the exercise 2.4. All the key concepts of the first chapter real numbers and the second chapter sets, and also all the exercises from real numbers and all the exercises from the sets are explained and posted the videos, and these links are given in your description. You may use them to revise the chapters thoroughly. Thank you one and all.